Steam-generated boiler. Part to C. In this section we discuss boiler drum and heaters. Steam drum internal. A. Steam purification equipment, including dry pan separators, plate-type baffles and other devices as necessary to meet steam quality requirements and provide proper water levels in the boiler steam drum. B. Boiler feed water admission system to properly distribute feed water. C. Chemical feed piping to permit infusion of mixture of water treatment compounds along entire length of drum by continuous feed system. D. Continuous blowdown and water sampling system as combined unit design to collect water along entire length of drum. E. Bottom drum blow-off system to properly collect sediment from bottom drum and to permit complete collection of sediment and drainage. F. Steam heating pipes in bottom drum to keep boiler warm on standby. Cap for future connections of steam supply and condensate return. G. Drum internal fittings shall be provided, securely mounted and easily removable for boiler internal access for inspections and cleaning. In this figure you can see the single row arrangement of cyclone steam separator with secondary scrubbers, and other view of steam drum. Mud drum. A drum beneath a boiler, into which sediment and mud in the water can settle for removal. It is related with bottom blowdown, which reduces the quantity of and dissolved solid sludge which collect in the lower parts of the boiler mud drum. Superheater coils. A superheater is a device used to convert saturated steam or wet steam into dry steam used in steam turbines or in processes, such as steam reforming. There are three types of superheaters: radiant, convection, and separately fired. 1. A radiant superheater is placed directly in the combustion chamber. 2. A convection superheater is located in the path of the hot gases. 3. A separately fired superheater, as its name implies, is totally separated from the boiler. A temperator is provided to control the superheated steam temperature. Reheater. Steam from the exhaust of the first stage turbine goes back to the boiler for reheating and is returned to the second stage. Reheater coils in the flue gas path does the reheating of the returned steam. The reheat steam is at a much lower pressure than the superheated steam, but the final reheater temperature is the same as the superheated steam temperature. Reheating to high temperatures improves the output and efficiency of the power plant. Final reheater temperatures are normally in the range of 530 to 600 degrees Celsius. Reheat steam pressures are normally around 45 bars. A temperator is provided to control the reheater steam temperature. Economizer coils. Economizer coils are used in downstream of boiler bank to preheat the feed water, absorbing heat from hot exhaust gases. Economizers are always water tube type. Economizers have different types of tubes depending upon the application. Bare tubes in economizers are widely used in industrial boilers and for applications like heat recovery boilers in sulfuric acid plants. Gulled tubes are employed. Fin tubes are popular in HRSG applications. Feed water can be heated up to a level about 20 to 30 occ below saturation temperature of the boiler. Downcomers. Downcomers are pipes leading from the top to the bottom of the boiler. Downcomers carry the water from steam drum to the bottom part of the boilers. Headers. Headers form an important part of all types of boilers. Steam from the generating tubes is collected in headers, which are therefore always under pressure. This pressure may vary from 300 psi to 2000 psi. Since headers are always under pressure, the utmost care is taken by us while fabricating them. Depending on the generating capacity of the boiler, the header sizes fabricated by us vary from 100 mm to 600 mm NB. The stubs of various sizes are very carefully welded to the main body of the header to provide the desired openings from the header. Water wall tubes. These are tubes in the boiler where water is evaporated to steam and are also called steam generating tubes. These tubes also form the walls of the boiler and are hence called water walls or water wall panels. These tubes have very complicated shapes to allow inspection, openings and burner throats, and fabrication require intricate binding on CNC programmable bending machines and checking on 3D layouts. SCAPH Steam Coil Air Press Heater. Steam Coil Air Preheater SCAF is an extended surface type heat exchanger. This equipment is used to heat atmospheric air to the required process temperature by means of saturated steam. Steam flows inside the tube while air passes over the fin tubes. Steam coil air preheaters SCAPHS are used to heat air entering the air heater recuperative or regenerative type in order to raise the average cold end temperature to prevent acid dew point corrosion. This type of equipment is normally incorporated into the design of a boiler unit for low-load operation and startup operation, particularly in those areas with low ambient air temperatures. They are desirable in that the main air heaters, recuperative or regenerative, have corrosion sections that are more readily maintained. This type of air heater uses extended surface, normally referred to as fins, to reduce the overall size of this air preheater. It is generally located in the duct between the FD fan and the main air heater. In those areas that have extremely low ambient air temperatures, it is common to have this ahead of the FD fan that could preheat cold winter air up to about 40 degrees F. Air preheater. In this type of preheater, heat is transferred from the flue gases to a matrix, which is then cooled by the combustion air, thereby preheating the air. For fired heater and boiler applications, regenerators are usually of the rotary type. The rotary regenerator preheater, known as the Lundstrom wheel, consists of elements, usually metallic, which are contained in a cylinder which flows through one side as the cylinder end is subsequently cooled by the combustion air on the other side as the wheel rotates. There are seals between the cylinder and casing to limit the amount of leakage from the air side to the flue gas side. This leakage lowers the gas exit temperature by 10 to 15 oC, which in turn limits the level of efficiency normally occur at the end of the elements, which will require periodic replacement. Soot blowers. A soot blower is a system for removing the soot that is deposited on the furnace tubes of a boiler during combustion. In all fired boilers, over a period of time the heat transfer tubes get covered by a layer of soot or fine carbon deposit. This reduces the heat transfer from the hot gases to the water and reduces the efficiency of the boiler. In coal-fired boilers, the furnace area gets covered by slag, which is molten ash. The ash also sticks to the heat transfer surface in the other heat transfer areas. These ash accumulations reduce heat transfer and increase the tube metal temperatures, leading to failure of the tubes. Types of soot blowers. 1. One with a very long lance called the long retractable soot blowers. This is normally used to clean the ash deposit from between the coils of superheaters and economizers. 2. The other type is the shorter lance type called the wall blowers. These are used to clean the furnace walls. The lance extends a short distance, around 200 millimeters from the furnace wall. The nozzle direction is such that the steam impinges on the walls, cleaning the surface. During operation, the lance rotates, cleaning the radial area covered by the steam from the nozzle. 3. Air heater blower. Soot blowing medium. Steam. Air. Steam is normally used as a medium for blowing away the soot, since capital cost of steam pressure reducing equipment and drain is less than the cost of compressor, motors and control of air systems. Thank you for watching. In next video, we discuss on boiler furnace and burners. Please keep watch my channel Shoaib Views. I like and share my videos.